What if the system gets stolen? That theft may position our clients in a situation in which they are out of compliance. We don't want to be the breach. Howdy, my name is Douglas and I'm a senior cybersecurity consultant here at Red Siege. In this video, I'm going to be walking you through the process of encrypting an entire file system while installing Linux to a virtualized environment. In doing so, we're going to be creating what we like to call in the industry a gold image. Now, this gold image is never actually used for an assessment, technically. Its main purpose is just to be a Linux-based system that we constantly update, add tools to, add our own tools that we're creating into it, and even theme it to fit like our reporting requirements and things like that. And then whenever we go to perform an assessment, we actually create a linked clone. That linked clone then thereby becomes a small container that holds all of our clients' data neatly for individual clients and assessments. Now, the reason why encryption is important is a topic that we could talk about for ages, forever, right? I mean, it should be its own video or maybe an entire course, but for the purpose of this video, let's just assume the scenario of, hey, what if our system becomes compromised via theft, right? Obviously there's ways to lock down our host operating system with remote wiping and remote locking it down, even encrypting the disk of the host. But what if the system gets stolen while we have a live session? Say we're on site with our clients, or say we're out in an office somewhere, or even working from home. Somebody comes in and takes our laptop and there's a live session. We briefly walk away to grab coffee. That threat actor may be able to access some of our client data from previous assessments if they just open VMware and start going down through the images and booting them up. Or grabbing the virtual disks and then mounting them. That's something that pen testers do on assessments whenever we find disk backups. It's a common thing to do. So obviously the encryption is going to be super important. Also, that theft may position our clients in a situation in which they are out of compliance. We don't want to be the breach, right? We don't want it to be our fault. Sometimes we do find those critical vulnerabilities in which we're reading databases, or we have remote code execution and we're sifting through files using Snaffler or some other tool to look for credentials. And we may be gathering potentially sensitive information in doing so. So we need to protect that information as much as possible. Obviously, we should be wiping these virtual machines after each assessment, but sometimes that can't be the case, due to data retention policies through your organization, or maybe you need it for the next coming up assessment with that particular client. So to begin, we're going to be using 3 different technologies. Obviously, we need a version of Linux, our favorite distribution, right? I'm going to be using Debian. The latest version of Debian is called Bookworm or Debian 12, and I highly recommend pausing the video and downloading it if you are a fan of Debian and you want to follow along with this video to get the hands-on experience. The next thing we're going to be using is this hypervisor tool. For me, I'm just going to be using VMware Workstation because I find that works the best for me. The last thing we're going to be using is called LUKS, L-U-K-S, and that is an acronym that stands for Linux Unified Key Setup, and that is the tool that we're going to be using to protect our clients' data, to encrypt those disks. It's built into the Debian installer and is very easy to use. We're actually going to be creating a logical volume and encrypting all of our drives in that volume, and then we're going to create a partition just for boot, just to keep that part plain text. So thank you so much for joining me in this video. Let's just dive right in. Okay, my friends, so here we are. This is the Debian 12 graphical installer. I first downloaded the NetISO image from the official Debian website, debian.org. I set it to be my CD-ROM image. I allocated 100 gigabytes of disk space to this gold image. I allocated 8 gigabytes of RAM space to this image, and I also allocated 4 CPUs to it. And I chose the graphical installer at boot. So this is what it looks like. Let's go ahead and start. I'm going to choose English United States and American English for my keyboard. The first thing we need to do is set the host name. For the domain name, I'm going to leave this blank. If you choose to use a domain name, just ensure that all of your other systems have the same domain name. I'm going to leave the root password as blank, which means the root can't log in, but that's okay. The user that I'm creating right here, the Douglas user, will automatically have sudo access. So if I ever need to perform administrative tasks, I could just use the sudo command. I'm going to choose my time zone here. Finally, we're getting into the disk partitioner. This is where the beef of this video exists. So I'm going to choose manual. I'm going to choose the disk right here. We see the 100 gigabyte drive that I allocated to this image. And then I'm going to create a partition table. Very simple, something that you definitely need. Here we are, finally in the free space. I'm going to create my first partition. So I'm selecting the free space here. I'm going to hit continue, create a partition. And this is going to be the boot partition. So I'm going to make it rather small. 2 gigabytes is kind of overkill, but it's the way that I learned. So I'm going to create a primary partition. We're going to start at the beginning because this is our boot partition. I'm going to change the mount point to be boot. I'm going to change the file system type to be ext2. I need to turn on the bootable flag, though I think you might not need it if you're using grub. So now that it's on, everything looks good. I'm going to click done setting up the partition. For the rest, I'm going to click on the free space here, and we're going to create a new partition. It's going to be the entire rest of the disk. It's going to be logical. So this part that says use as, I'm going to click continue, and we're going to create a physical volume for encryption. I'm going to click continue here. And everything looks okay. We use a device mapper, AES-256, looks good. Our initialization algorithm looks good. We're going to be using a passphrase for sure. It's not going to be bootable, and it's going to erase data if data is there. Done setting up the partition. I'm just going to hit continue here, and that's it. Now we have these two items right here. The next thing that we want to do is I'm going to choose configure encrypted volumes. So I'm going to hit continue, going to hit yes right here. Create encrypted volumes, continue. And we're going to choose this because remember SDA1 is going to be our boot partition. I'm going to hit finish, continue. Going to hit yes, and this part should take quite a while depending on how much disk space you allocated to this partition. All right, we're back. That took quite a while. So now we finally get to choose our passphrase. And obviously, the longer the passphrase is, the harder it is for threat actors to be able to decrypt or crack the passphrase. So I'm going to choose one here. I'm going to hit continue. The next thing we want to do is configure the logical volume manager. So I'm going to choose that and hit continue. And then here I'm going to continue as yes. We're going to create a volume group. I'm going to call this pen test VMVG. Continue. And we're going to use this one right here, the one that's crypto. It's a SDA5_crypt. I'm going to click continue. So now I'm going to create a logical volume right here. I'm going to hit continue. We're going to choose this volume group that we just created. I'm going to give this one a name, and we'll call this one root. And okay, so for root, we get to choose how large the volume is. So I'm going to get rid of all of this, and my root partition is rather overkill. I'm going to choose probably about 40 gigabytes. And the reason why is because I choose to place all of my pen test tools in one area, and I keep all of my Python virtual environments and everything in /red team, which is in the root. So I'm just going to choose 40 gigs here. And I'm going to create another volume. I'm going to choose this one again, this volume group that we just created. This one's going to be var. And var, obviously, it depends on what your usage is. I know that I use Apache a lot. So the Apache default directories like /var/www/html. And I kind of just like to keep things that way. But for this, we're just going to delete this. I'm going to make this one 10 gigs in size. Hit continue. And I'm going to create another logical volume right here. Choose our volume group. And this baby is going to be our temp, or temporary directory. Now, again, this is completely up to you to choose this size. I know a lot of applications use the temp area, especially VMware applications and such. So I'm going to keep mine to 5 gigabytes in size. I'm going to create another logic volume here for swap. So this is going to be our swap space. Now, the reason why you want to encrypt your swap space is because swap will contain stuff from memory sometimes. A lot of times when I'm using Linux, I don't even see swap being used. But if it is used, it may dump RAM information into your file system into this here partition. I'll call this one swap. So obviously you do not want that to get into threat actors' hands in plain text. And for the swap partition, I have 8 gigabytes of RAM allocated to this system. So I'm going to choose 10 gigabytes of swap space. I'm going to create another logic volume. This one's going to be /home. I don't put much stuff in /home. As I said before, most of my tools are just in /red team. Okay. Unless they're installed by the package manager, that is. So I'm just going to leave this as it is. It's just going to contain, it's just going to suck up the rest of the hard drive space. I'm going to hit continue here. I'm going to display configuration details and hit continue. And we can see all of the drives right here. First of all, we have our volume group, which is pentest vmvg. And then we use as a physical volume, which is this drive right here, the crypto drive. And then we have home, root, swap, temp, var. I'm going to hit continue. I'm going to hit finish. And now for each one of these, I'm going to have to go down and choose the file system type and the mount points. So none of these are going to be bootable, but that's okay. So the first one I want to do is, let's just do home. Let's just go down through the list. And I'm going to hit continue. I'm going to click do not use right here. Do not use for all of them, actually. We're going to choose ext4. Our mount point is going to be /home. Everything else looks okay. Done setting up this partition. The next one we're going to go down to is the root partition. Continue. Do not use. And then we're going to select ext4. This is fine. And then our mount point, which is going to be the root file system. Continue. And then everything else is okay. We're done setting up this one. Also, the next one is our swap. This one's really easy. Just a couple of steps here. Do not use. Then we choose swap area, and that's it. Essentially done setting up the partition. /temp is the next one. I'm going to, again, just going to click do not use. And then we're going to choose ext4 is fine. And our mount point is going to be /temp. Right here, temporary files. Continue. And then done setting up this partition. Continue. The next one down here is the var /var. We're going to hit continue. Do not use. And then ext4 is fine. And then our mount point is going to be /var. Done setting up this partition. This is the entire encrypted volume drive right here. And then this is going to be our boot down here. So that's good to go. We're going to finish. And we're going to click finish partitioning and write changes to disk. Hit continue and just let it go. Now we're going to be installing the base system, and the rest of this process is completely up to you. The purpose of this video, again, was just to show you the encryption process and setting up the different disk drives and creating a logic volume so that we only have to put in one passphrase, but we're still protecting our client's data for every single linked clone to this image. For the grub loader, I'm just going to choose yes right here and hit continue, and we're going to put it into SDA. Dev SDA should be fine. Okay, that's it, my friends. We're all done. I'm just going to hit continue to reboot the system, and I'm going to show you what this looks like when it boots up and asks for the passphrase to decrypt the drive. So here I'm just going to hit enter. And there it is, my friends. And there we go. Okay, so this is our system. We've booted into our system, and one thing I'd like to say first and foremost is that if you do have to change the root password, you totally can. Open up a terminal prompt and type sudo su and put in your user's password. See, now I've become root. I could type password and then hit enter, and then see, it just doesn't ask for a current password, it just asks for the new password. So that brings us to the last demonstration, and that is changing the LUKS password or the passphrase used to encrypt the drive. Now we're going to need two things, actually three things to do that. We need the drive itself that's encrypted, we need the path to the drive, and we also need what's called the key slot. And I'm going to show you how to get that information. So the first thing we're going to do is sudo cat etc crypt tab. And we see that this was SDA5 crypt. So I'm going to type now is fdisk, because we know SDA. I'm going to type, actually I'm going to do sudo fdisk -l/dev/SDA, and you're going to see that this is the path to the drive. The last thing that we need is the key slot, and that's easy. We do sudo crypt setup --verbose open --test -passphrase. Now dev SDA5. Now this is going to test our passphrase and ensure that we know the passphrase for the drive. And in doing so, it's going to spit out the actual key slot. So here I'm going to enter the passphrase. And now we know that it is in fact key slot 0. Now this is probably going to be the same on your system if you follow it along with this, but taking these extra steps is just being extra careful, and that's never a bad thing. So finally, to change the passphrase, we're going to do sudo crypt setup again. But this time we're going to be passing it a command. Setup, and that command's going to be LUKS change key, and that's camel case. So move me out of the way here. Yeah, LUKS change key, and then we're going to do the path that we just got, dev SDA5, and then we're going to specify the slot, or the key slot, with -S and then 0. Hit enter. Enter passphrase to be changed. So I'm going to type in the passphrase here that I set up at the beginning. And now it's asking me for a new one. And that's it. I'm just going to go ahead and reboot, and we're going to test the passphrase and make sure that it did in fact take. Okay, so here we go. And that's it. It worked. We successfully changed our LUKS password, and we went through the entire process of encrypting the drive to be used for our Linux Gold image that we use to create clones of for every single engagement.